This is chapter 7, which we're going to talk a little bit about 7.1 and 7.2 today, which is exponential expressions and multiplying and dividing monomials. Now, some of these words we haven't seen. Monomials we haven't seen yet. Exponential, though, what's an exponential? Or what's exponent? With exponents, right, dealing with exponents. Okay. So, and then we're multiplying and dividing something we call monomials that we're going to talk about in just a second. Okay.
We learned those last year.
So, first we need to know what a monomial is, okay? This would be an important thing to know what a monomial is. It's one of three things. It can either be a constant number, things just like whole numbers, 5, -21, 0, okay? It could be a variable by itself, x, y, z, n, whatever, okay? Or it could be a product. What's a product mean?
Answer to
Very good. Yep, that's right. Answer to a multiplication problem. It could be a product or multiplication problem of a constant and one or more variables. This will be the most common that we see monomials. Things like 2x, that's a monomial. 4ab squared, that's a monomial. -7 m to the third n to the eighth, that's a monomial. So it's just kind of like a clump of multiplication problems. Okay? It's got variables, it can have more than one, it can have different exponents, it can have constants in front. Okay, so it could be just a constant, could be just a variable, or it could be a group or a product of constants and variables with any exponents. Okay. So let a group of there. Let's review what an exponent is. 2 to the 5th power, which is 2 times 2 times 2 times 2 times 2. Okay. We know a base, the little number in the top right is the exponent. Okay. So what does 2 to the 5th mean? It means we multiply 2 5 times. A lot of people say the answer to this is 10 because they do 2 times 5, right? But it's 2 times itself 5 times. We've seen that before. Okay. Now, these ones are just review with exponents, that's all right. So now when we have a -4 to the third, this means that this is -4 times itself 3 times, right? So -4 times -4 is going to be positive 16 times another -4, -64, right? So be sure to carry that negative if you have one in parentheses. Yeah.
Is it always if it's a even number, if the exponent's an even
Good point.
number?
Good point. Yep. If the exponent's even, it means you're going to multiply negative an even amount of times. So it means it's always going to spit out a positive. Now, a difference though, what if it was like this? This may necessarily not be positive because in this case, this is just saying what's the opposite of 2 squared. Okay. It's going to be -4 because that's different than this. It is negative because this would be positive 4 because this is -2 times -2. So the parentheses matter. Okay. This is just -2 squared. Right. So it's 2 to the 4th power with a negative in front. In this case with the parentheses, this is -2 times -2, which is positive 4. Okay. So if it has parentheses around it, you have to keep the negative with it. If it doesn't have parentheses around it, the negative just stays out front.
So that one.
Now we're going to talk about multiplying with exponents. When we multiply with exponents, we add the exponents. So if I take x to the 3rd times x to the 5th, if I was to write that out longhand wise, that would be like x times x times x, right? Times, right? Everybody agrees x to the 3rd is that? This would be x times x times x times x times x, right? So x to the 3rd times x to the 5th. I want to know, what does that equal? Well, it's going to be x to the, how many times did I multiply x by itself? 8, right? Because there's 8 of them here. So when we multiply things of the same base, we add their exponent. 3 plus 5 is 8. That way we don't have to write these out every time, right? That way we don't have to write x to the third out with 3 of them and x to the fifth out with 5 of them. Let's say, again, what exponent is there when we don't write it? There's like a 1 there, right? So this is like y times y, which, how many times did I multiply y by itself? 5. Because I added the exponent. When you multiply same bases, you add the exponent. Y to the fourth times y to the first is y to the fifth. Yes, question.
And when it's just, the problem's over, right? Y to the fifth?
Yes, it's just y to the fifth because that's y to the first. Right. Okay. So this is one giant multiplication problem, right? There's no addition here. There's no subtraction here. This is times, parentheses, times. This is all one giant multiplication problem, right? Okay. So what's the exponent for that x there? It's just to the first, right? Just a 1. We don't write it there. Okay. First, we're going to multiply the coefficients. What's a coefficient again? The number in front of the variable, right? So in that case, we're going to multiply these two numbers because this is just one big multiplication problem. Okay. So we're going to multiply those to get negative 12. This would be a good problem to have written down.
You don't add this?
Because this is, right, the numbers, we will only add the exponents. The numbers, this is still one big multiplication problem. Good point, okay? So then we're going to look at the x's. Let's multiply the x's together. I have x to the fifth times x to the first, which means how many x's am I multiplying together? 6 of them, because 5 plus 1, right? I have 6 total x's. So that's going to be x to the sixth, right? And then I'm going to move on to the y's, okay? And I have y to the third times y to the second, which means that's going to be y to the fifth, because I have 5 of them that I'm multiplying, because I'm adding the exponents.
I get this.
But I had a very good question that said, why didn't I add the negative 4 and 3? Because it's still one big multiplication problem. I only add the exponents because that's how many of those exponents I'm multiplying together. That's the answer. Can't go any further. I'd like you to take a minute and try this one first in your notes, and then we'll go over the answer together. So let's check this one together. Again, this is one big multiplication problem. So let's multiply the coefficients together. That's going to be 10, right? Let's look at the x variables. I have x to the second, still all one big multiplication, times x to the third, which is going to give me x to the what? Fifth, because I just add 2 and 3. Y to the third times y to the fifth, y to the eighth. We're going to talk about the question I had earlier, raising a power to another power. When raising a power to another power, okay, we're going to multiply the exponents. This is another rule that you'll need to know. When it's a power to a power, we're going to multiply the exponents, okay, instead of add like we did before. For example, this is like a to the second power to the third power again, right? So if I was to write this out longhand, it would look like this. It would look like a to the second times a to the second times a to the second. 3 different times, right? Because it's a to the second times itself 3 times. And just like before, when you multiply the same base, you add the exponents. Or, our new rule, when we have a power to a power, we multiply the exponents. So that's going to be a to the sixth. Okay. So this is the other rule we're going to talk about today. When it's a power to another power, you multiply them. Yeah.
When you see that in a problem,
Yep.
you automatically know to get rid of them, put them together.
Uh-huh. You mean you don't have to do this?
Well, I mean, but you just know that you have to
Multiply those?
Yeah.
Yeah, yes. And just do it right there. You don't need to write out this or anything like that. This is just a longhand rule. When you have a power to a power, just go ahead and multiply. Yeah.
So we just multiply the 2 and we just add it to the
Yep, just keep it with the coefficient, right. Okay. So this one, when you have x to the 4th to the 5th, is going to be x to the 20th, because it's a power to a power, so we multiply. Okay. Now I have x to the 3rd and y to the 4th, all to the 2nd power. Okay. When this happens, we're going to take everything in the parentheses and raise it to the 2nd power. Take them individually. Okay. So we're going to take x to the 3rd to the 2nd when it's a power to a power, which means we're going to get x to the 6th, right? Because it's 3 times 2. Then we also have to take y to the 4th to the 2nd. It's a power to a power. So we're going to multiply those and get y to the 8th. Okay? That's all the further we can go. So this was a whole monomial still. This is one monomial, because a monomial is a group of multiplication of variables with exponents or just constants. Okay? We multiply. So let's look at this one. Multiple exponents here. This is x to the n plus 2 power, all raised to the 5th power. And the rule again is whenever you have a power to another power, you multiply the exponents. Okay? So we're going to multiply this exponent times this exponent. But since we have to put that in parentheses because we're multiplying by the entire thing. So it's going to be x to the 5n plus 10. Right? Because I had to distribute that 5 to that entire power. I had to multiply a power times a power. Okay. This is the monomial 2a to the 3rd, b to the 4th, all raised to the 3rd power. Okay. So this is like I'm multiplying by this chunk of stuff by itself 3 times. Okay. This monomial is to the 3rd power 3 times. Okay. Oops, let me go back here. So, remember we have to take that power to everything that's on the inside of the parentheses. So what exponent is on that 2 that we don't usually write? It's like a 1, right? It's a 2 to the 1st power. So we're going to take this power and multiply it to each of these pieces of this monomial. Whenever it's a power to a power, we multiply. So 2 to the 1st to the 3rd is going to be 2 to the 3rd, because 1 times 3 is 3. A to the 3rd to the 5th, or sorry, a to the 3rd to the 3rd is going to be a to the 9th, because it's a power to a power. Yes.
Do you add a 1 if there's a number?
Right. If there's no exponent there, it's a 1. And then b to the 4th to the 3rd is going to be b to the 12th. It's a power to a power.
This is just.
Can't you multiply the...
Good. And we want to simplify any further if we can. We don't know what a is, we don't know what b is, but we know we can simplify 2 to the 3rd. Right? Because 2 to the 3rd, it's not 6. Because 2 to the 3rd is 2 times 2 times 2. Which is 8.
So every time you see a number, you add a 1?
Yeah, if there's not an exponent, you can assume it's a 1. Right.
How'd you get the 8? Sorry.
I got the 8 because I simplified this 2 to the 3rd, which is like 2 times 2 times 2,
Okay.
which is 8. Yeah. And that's our answer. Here we have a monomial times another monomial that's raised to a power. Okay. We have a monomial times a monomial that's raised to another power. Okay. So, first, what exponent are we going to treat there with the x? That's a 1, right? Same with this x over here. We're going to treat that as a 1. We just normally don't write the 1. Okay? And if you can remember there's a 1 there, you don't need to write the 1. We're going to simplify this expression first because it has the outside exponent. Just like in PEMDAS, okay, when we deal with parentheses and exponents, okay, Because this one has an outside exponent, we're going to simplify it first. Okay? Which means we do just like we did before, where we have each of these pieces of the monomial are going to be raised to the third power. Okay? Take everything in that parentheses, raised to the third power. So I just left alone this monomial. Yeah, question.
Could you not, like,
That's like saying you're doing multiplication before exponents. You have to do the exponent first. Good question. Okay. Right. We cannot combine these x's first because we have this one is raised to a power, and we're always going to take care of exponents first. Okay. So when we take each of these to the third power, remember this -3 is in parentheses here. So when it's to the third power, it's going to be like -3 to the third power, which is -3 times -3 times -3, because it's in parentheses, right? So that's going to be +9 times another -3, which is going to give us -27 is going to go there. Okay. Then I'm going to take x to the first to the third, which is going to be x to the third because you're just multiplying 1 and 3. Okay. And then I have y to the fourth to the third, which is going to be y to the 12th because it's 4 times 3. Okay. Now it's all one big multiplication problem, so we're going to start multiplying our coefficients, our x variables, and our y variables. Yeah.
And why would it be -27?
Because it's -3 in parentheses to the third. So it's -3 times -3 times -3, which would give you -27. Okay. So now I'm going to treat it each as just one big multiplication problem. There are no outside exponents, so we can multiply the coefficients. That is, we multiply the 2 and -27, which is going to give us -54. Okay. We're going to take the x to the first times the x to the third. Now remember, this is like I'm multiplying one x times 3 other x's. So when we have the same base, what do we do to the exponents? We add them. So it's going to be x to the 4th. Right? Because I have 1 here and 3 of them here that I'm multiplying. And then finally I have y to the second times y to the 12th. So when we have the same base being multiplied, how many y's am I then multiplying together? That'll be 14. So this would be our final answer.
So you take -27 times 2?
Yes, that's how I got -54. Yep. Last one I want to talk about with multiplying monomials. Okay, probably another good one I would have written down. Now we have brackets and parentheses here, so let's look at what's happening. We have this monomial, 2x y to the second. We're going to raise it to the second power, and then we're going to raise it to the third power. Okay. So we have this monomial on the inside, 2x y to the second, to the second, to the third. So this is the stuff that we're going to raise to the second power, and then we're going to raise it to the third. So there's nothing else. We could really do this one of two ways. We could first multiply these two exponents together because it's a power to a power. So we can make that this 6. Or we could start on the inside and work our way out. Okay. Let's say we're going to start on the inside and work our way out. So we have 2 times x times y to the second. So whenever we have a monomial to the second power, we're going to take that power and multiply it to each of the powers inside. So remember, that's like 2 to the first. So 2 to the first to the second is going to be 2 to the second, right? Because there's like a 1 there. And we have a power to a power, so we multiply. We have x to the first to the second, which is going to be x to the second. And y to the second, which is going to be y to the 4th. And now I've worked those parentheses, so what I have left is to the 3rd. And I'm just going to repeat the process again because I have everything a power to a power. Okay. So I'm looking to take that to those. 2 to the second to the 3rd. It's going to be 2 to the 6th because I'm multiplying 2 and 3. X to the second to the 3rd is also x to the 6th. and y to the 4th to the 3rd, going to be y to the 12th. Now again, the other way you could have done this problem is I could have multiplied these together to start with, and then had 2xy to the 2nd to the 6th, and then took that to each of those, and got 2 to the 6th, x to the 6th, y to the 12th. See what I did? Yes, question. Go ahead and simplify this. The answer is yes. Go ahead and simplify that 2 to the 6th. So that's 2 times itself 6 times. 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32, times another 2 is 64, right? So the final answer would be 64 x to the 6th, y to the 12th.